Let's read over this one here. It says the elevation, E, so E is the elevation. So we're going to input something and get out an elevation. The elevation in meters above sea level at which the boiling point of a certain liquid is T degrees Celsius. All right, so when the boiling point is T degrees, T and T, you can put that in here and compute and you get the elevation. So what do we want to know? Is given by this function. Okay, so now, at what elevation? So at what elevation? At what E? All right, so find E when the boiling point is 89.5 and then 90. So here's what I'm trying to find. I've got two variables here. I've got T and E. Which one do we want to find? We want to find, okay, this is part A, I guess. Find E when T is, right, the temperature is 89.5. All right, so what I'm going to do is I'm going to get my calculator and I'm going to put 89.5 in here and here. Now, I'm going to write this formula a little bit bigger. E of T is equal to 1,300 times the quantity, 90 minus T, plus 540 times the quantity, 90 minus T, and that's squared. So now what I'm going to do is find E of 89.5. So all I'm going to do is look at the formula here. What I did is I replaced that T with 89.5. So replace all the T's with 89.5. So it's going to look like this. This will be 1,300 times the quantity, 90 minus 89.5 plus 540 times the quantity, 9, is that 9 or, oh, it's 90, it's 90. 90 minus T, now T is what? T is 89.5 squared. So calculator for sure, right? Get your calculator out. So on your calculator, put in 1,300. Now left parentheses, 90, and then a minus sign, and then 89.5, right parentheses, plus, type in 540, parentheses, 90 minus 89.5, close the parentheses, and then you can either press the X squared key that's on the left side, or you can press the up arrow key. Either one will work. And when you press enter, you get 785. Well, that's what I got anyway. So here's what this means. At an elevation of 785 meters, a certain liquid will boil at 89.5 degrees Celsius. Now here's another way to do this computation. Let's go to Wolfram Alpha. If you have your computer with you, go to wolframalpha.com. This screen will come up. Now, Wolfram Alpha is a computational intelligence engine. As you can see, that's what it says it is here. And what we're going to do is we're just going to type what we want in here. So here's what we're going to do. Get your cursor right here. It's probably there already. And in this field here, type in the 1,300 times, well, type in that expression. Here's what mine looks like. I typed in the expression. I typed in evaluate. I have to tell it, I don't have to, but I'm going to tell it what to do. What do I want it to do? I want it to evaluate this expression. So I just type that in. Now, once you get that typed in, just press the enter key, and it will think for a minute, and it will come back with the answer. And here it is, 785. So you can see it's going to tell you what it thinks it's you're inputting. So you type in, up here at the top, you say evaluate this. It'll think for a second, and then it will tell you this is what I think you put in, and this is what you should get out. 785. Now it gives you some other things down here too, but there's the answer right there. So there is our 785. Now, part B asks us, what are we going to do here at 90 degrees? All right, so this is part B. So in part B, 90 degrees. So all I'm going to do here is I'm going to go back here. All right, I'm going to take that 90 degrees, and I'm just going to go back to my computer. I'm going to replace 89.5 with 90. All right, so replace those with 90. Now, can you see what's going to happen here? At 90, what do you get? Well, 90 minus 90 is 0. 1,300 times 0 is 0, plus 540 times 0. 0 squared is 0. This whole thing comes out to be 0. Now, you can certainly use Wolfram Alpha or your calculator to do that, but look to see what number you're going to put in first and just kind of see what's going to happen. Now, I can see that that's going to be 0, so E of 90 is 0. And what does it mean? When the input is 90, the output is 0. Now, what is the input? The input is the temperature, and the output is the elevation. So I'm going to write this like this. At an elevation of 0 meters, right, the elevation is 0. At an elevation of 0 meters, a certain liquid would boil at 90 degrees Celsius. Let's read number 16. It says, in 2005, it took 19.09 currency units. Okay, that's awkward. Just think dollars. All right, so back in 2005, it took $19.09 to equal the value of $1 back in 1917. All right, so here's what I'm thinking. In 1917, maybe you had $1, okay? No, that's not even readable. Okay, let's try that again. Okay, so you had $1. Now, in 2005, that $1, to buy something for $1, it took $19.09. Then in 1990, it took only $12.90 to equal the value of $1. All right, so now we're given this. In 1990, okay, it took $12.90. All right, so it looks to me like back in 1917, you buy something for $1. In 2005, it takes $19.09 to buy that same thing for $1 that you could buy for $1 then. But back in 1990, it took only $12.90 to buy that same thing you could buy for $1 back in 17. Now, what's going on here? It says, okay, down here, right, the amount it takes to equal the value of $1 in 1917 can be estimated by this linear function right here. Okay, I'm going to write a little bit bigger. It says v of x, v for value probably, is equal to 0.4195x plus 13.4501, where x, all right, where x is the number of years since 1990. Okay, so this says the value. If you know the number of years since 1990, the value of that, this is the number of years since 1990. So like V11, that gives you the amount it took in 2001, right? 1990 plus 11 is 2001, to equal the value of one currency unit back in 1917. All right, so complete parts A and B below. So here is A. A is this. A says, use this function to predict the amount it will take in 2014 and 2022 to equal the value of, say, $1 back in 1917. Well, all right, what is X? X is the number of years since when? Since 1990. All right, so we're going to have 2014 minus 1990. That is 24 years, all right? So X is equal to 24. So we want to find V of 24. So you can put that into your calculator. You don't need the 0. Just put in 0.4195 times 24 plus 13.4501. So I compute that like this. I get 24 years after 1990, it takes $23, now I'm going to round off here, and 52 cents to buy something that cost $1 back in 1917. So I'll write that here. I mean, it's nice to get a number, but it's even nicer if you can interpret it for somebody. So in the year 2014, it takes $23.52 to buy something that costs $1 back in 1917. And if you want to do this in Wolfram Alpha, I would type in evaluate. Now, you don't really need the evaluate, but if you don't type in evaluate, down here in the answer, it might give you a whole bunch of stuff because it really doesn't know what you want. So I typed in 0.4195 times the 24 plus 13.4501. It said, this is what I think you typed in, and here is my answer. Right, then all I have to do is interpret it.